doing them in chunks.
Ah, good idea.
Wow.
All right, so I lost my train of thought. I know what I was gonna say.
You were talking about.
Yeah, what was I even talking about? I was talking about
Four-dimensional spheres.
Right. So four-dimensional hypersphere, and our universe is the three-dimensional surface of it. So how would we measure that surface? We could measure it making a triangle. You could make a triangle, and if the angles are more than 180, that means that the universe is curved. That also means that if you look far enough into space, much like you can imagine the sphere analogy, see the light would go all the way around, and you'd eventually be able to look far enough and you'd be able to see the back of your head very, very far away, and you wouldn't be able to see it because it would be too far away to see, but it would. And of course the theory of that is that the universe is so big that we can't see all of it yet, and because it's expanding we might never be able to see all of it. But forgetting about the speed of light and all that stuff, you would theoretically be able to see all around, and you'd be able to travel in a straight line, and eventually you'd be able to go right back to where you were at first. Just like if you walk in a straight line and you get a boat whenever you have to go in the ocean, eventually you'll get right back to where you started. The theory is you can do that with the whole universe too. So you measure that by making a triangle. So you can draw a triangle and make a triangle, and you can measure the angles and add up to almost exactly 180 degrees. But because you have some error in your measurement, that means that either the universe is flat or it's really big. So you can measure using a bigger triangle. So how about using a triangle, I don't know, like the size of the solar system, to measure the curvature of the universe? You could construct these huge steel beams, and you could make a huge triangle and measure the angles. But that's not the best way to do it. The best way is with lasers, and scientists did that. They decided to just use these big lasers, and they somehow figured out how to make their own imaginary triangle that was huge. So this was a really big triangle, the biggest triangle I think humans have ever constructed. I don't remember how they did it or anything, but I think I understood it a few months ago, back when I was researching this topic a lot. And they measured the interior angles of the triangle, which should have been 180. It might have been a tetrahedron, but I'll just say triangle for simplicity's sake. And the angles added up to almost exactly 180. This was a really big triangle, so it went, I think it was millions of light years in size. And it was really precise as well. So a lot of people misinterpret that data, and they think that because the angles added up to 180, that means, well, the triangle is huge, and the triangle showed that we have a flat universe. No, it didn't show that we had a flat universe. It showed that the curvature is either very tiny, or it is not there at all. But unless we have infinite measurement, we cannot say with infinite precision what the results are. So basically, the universe is either really big, or it is really huge, or it is completely flat, and that would mean it's infinite. Just like if you imagine planet Earth not being a sphere, but being a landscape that is infinite and not curving at all, it would extend infinitely. But Earth can be continuous, but it will eventually wrap around itself. Same with that universe. And I think the figures on that would be it would have to be 10 to the power of 46 meters in diameter or something, which is really big. So to get a scale for that, Earth to the Sun, that's about 150 million kilometers, so that's about 150 billion meters. So that's about 10 to the power of 11 meters, right? So 10 to the power of 40 is compare a meter from the distance, compare that from the distance from Earth to Sun, and imagine the Earth to Sun distance is a meter, and use the actual Earth to Sun distance, and then you get this value of about 10 to the 22, and if you do that again once more, actually no, 2 more times, then you'll get about the minimum size of the universe, for if this curvature theory is correct. And yeah,